Hello everyone, welcome to Leap, where you learn once and remember forever. In the previous video, we saw what are the laws of exponents or the index laws and the explanation of why these laws exist and how to go about them. Well, in this video, we are going to look at how we will apply those index laws or the laws of exponents to simplify them, right? Let's get started. So let's start with the first one. So here you can see that this is a much simpler question. The first one has a positive index already, but the second one you can see it has a negative index. So whenever you have a base with a negative index, we have already seen that we have to take the reciprocal of the base, right? So what you can do here is you can just make this as the denominator for the first term here, okay? So in order to rewrite that, I'm going to do 2a squared b cubed, the whole cubed, over 3a b to the power 4, the whole to the power of positive 2 as an exponent. Now I can bring down the exponents. When I say bring down, you're going to bring down the exponent for each and every number and variable in this question. So that makes it 2 cubed. And then a to the power of 2. So you already have an a squared where the exponent is 2, and then you're going to raise it again to an exponent 3. So this is another law that we saw, which is law number 3. So you can see if you have a to the power n, and then you raise it again to the power of something, you just multiply the exponents, right? So we're going to do the same thing here. So 2 times 3 is going to give you 6. Do the same thing for the next one. So it will be b to the power of 3 times 3, which is 9, over doing the same thing for the denominator. You have 3 to the power of 2, so 3 squared, and then a squared, and then b to the power of 4 times 2, which is 8. Now we can apply the law of index number 2, which is when you have same bases and then you have division in between, you subtract the exponents, right? We'll do that. Before doing that, if you look at these numbers, they don't have anything in common. Like they don't have the same base, they don't have the same exponent, nothing, right? So the numbers will be as it is in its simplest form. So 2 cubed, when you simplify, 2 times 2 times 2 is going to give you 8. And over 3 squared, it's 9, 3 times 3, right? Don't write it as 6. Many people do that. So 3 squared is 3 times 3, not 3 times 2. All right. Then we'll apply the law of index number 2 for a and b. So base is a. You subtract the exponent 6 minus 2, that is 4. And same thing happens with b. You do 9 minus 8, you get 1. So you can either choose to write it as b raised to 1, or you can just choose to write it as 8 over 9. a to the power of 4 and then just b. So this is the answer for question A. Now let's move on to question B. The first part, it's already nice and simple. It has got positive exponent. So you just have to bring the exponent down to the numerator and denominator. And the right hand side is where you have a division in between. So that makes it a little bit more tedious. So there are multiple ways in which you can solve this. One method would be you can either choose to simplify the base in the brackets and then work on the exponents later, or you can choose to bring down the exponents and then work with the base. I would prefer working with the base first and simplifying it, then applying the exponents inside. So let me show you how that's done. So numerator, denominator, you can see that there are two variables a and b that have got the same basis, right? So what I'm going to do is I'll keep the 2 as it is. Now these are all within brackets, so I'm going to keep them as it is, okay? Now a, you can see that a raised to 3 and you have divided by a. Now if it is just a, it means the power is 1, right? The exponent is 1. So apply the law of index 2. You can subtract the exponents. 3 minus 1 makes it 2. Then go to b. So you have b 2 here and then divide here, and then there's only 1b here. So that will be 2 minus 1, which is 1. I can choose to write 1 here, or I can choose to just leave it as it is. I would just leave it, okay? And then c squared, there's no other c on the top. That's going to remain in the denominator itself. Make sure you are writing that in the denominator, because in the question it is in the denominator, okay? And then you have divided by all these raised to power 3. Now you can actually bring down this exponent for each of these here if you want. So in that case, it would be a cubed b to the power of negative 1 times 3 becomes b to the power of negative 3. B to the power of negative 3. That's it. And then c cubed as it is. Now we can simplify again. Now you can bring down this 3 to each and every number and variable here. So that becomes 2 cubed, and then a to the power of 2 times 3, because it's power of power. So that's 6. And then b cubed over c to the power of 2 times 3, which is c to the power of 6. And then divided by a cubed b to the power of negative 3 c cubed. If you want here at this stage, you can bring this b to the power of negative 3 down to the denominator to make it positive. It's up to you. Okay. Now I'm going to work with the numbers first, and I have only 2 cubed. I can't simplify that further. I'm going to leave it as 8. And then next is a to the power 6, b to the power cubed, and then a to the power 6 b cubed over c to the power of 6, right? And now I'm going to change this division into multiplication. If I continue like this, what will happen is when I do the law of index for this c cubed and this c to the power 6, 100% it will go wrong, okay? So in order to avoid that mistake and the misconception, I'm gonna convert this division to a multiplication. So how do we do that? You gotta convert this as a fraction by putting an over 1, and then change this division to multiplication and take the reciprocal of this. So that will be and that will be 1 over a cubed b to the power minus 3 c to the power 3. The exponents will be as it is with whatever sign it has got, because it is just the reciprocal. You're not trying to change the exponents from negative to positive or anything, okay? Now you can actually go ahead and apply the laws of exponents. That will give you 8. And let's start with a. So we have a to the power of 6 and then divided by a cubed. So when we have divide, we know it's subtraction of exponents. So 6 minus 3, right? And then b to the power of, we have 3 here, again division, negative 3, so minus of minus 3, which is going to be plus 3, right? And then c is both in the denominator, so it has to be in the denominator, okay? And within the denominator, it is in multiplication. Both are in denominator, so they are in multiplication. So you will add the exponent, so 6 plus 3. So that will give you 8, a to the power of 3, b to the power of 6 over c to the power of 9. That's it. That's the answer for question B. Now the first part, you already see that it's a positive exponent. You just have to bring down the exponent to each and every number and the pronumeral here, right? So that would become 3 cubed and then a raised to 4. And then it is again raised to 3. So power of power rule, 4 times 3 would be 12. Next step is B. Same thing, 3 times 3 will become 9. Now, before you proceed to the second term, before you simplify that, you can see that it has a negative exponent. Now, in order to change negative exponent to positive exponent, we need to push them up or down, right? Numerator or denominator based on where they are. Now, this is already in the numerator. You got to push it to the denominator. So I'm going to put that as a division sign. and then bring this down as 4a squared b to the power of 4 whole raised to positive 2. And then you can bring down the exponent for this. Before I do that, I can simplify 3 cubed as 27, 3 times 3 times 3, and then a to the power of 12, b to the power of 9 over 4 squared, right? So 4 squared, and then a to the power of 2 times 2 is 4, and then b to the power of 4 times 2 is 8. Now, again, simplifying the numbers, 27 over 4 squared is 16, not 8. Don't write 8. Many people do that. It's 4 times 4, not 4 times 2. Okay. Then you can see that the rest of the terms that you have, they can be simplified by the index law number 2, because you have the same base and different exponents, and you have a division in between. So common base is a. When you have division in between, you subtract the exponents. So 12 minus 4, which is 8. And then you have b as the common base, subtract the exponents. 9 minus 8 is 1. Either choose to write the 1 or just ignore it and put it as b. So that's the answer for part A. Now part B, question B, again, I'm going to simplify the base first because I see a lot of common bases here within the base. So that would be 5, keep it as it is. I'm going to change the a. So you can see here a to the power 3, and then here it is just 1a and division in between. So 3 minus 1, which is 2. Again, do it with b. 3 minus 2, which is 1. I'm going to leave it as just b. And there's no c other than the denominator 1, so I'll just put it as c squared. And whole raised to 3, don't forget that. Now we have a division here, and you can choose to actually bring down the exponent to individual numbers and pronumerals. So that would be a squared raised to 3, which is 2 times 3, so a to the power of 6. And same thing, negative 1 times 3 is negative 3. Don't subtract this as minus 1 plus 3 and write 2. That will be wrong. You're doing power of power rule, so you multiply the exponents. Okay, and this will be c to the power of 3. Done. Now, again, simplifying this further, you just have to bring down the exponents. That would be 5 cubed, and then a to the power of 2 times 3, because exponent of another exponent. So 6, and then b cubed over, again, c squared raised to 3, which is c to the power of 6, divided by a to the power of 6, b to the power of negative 3, c to the power of 3. Now we can choose to apply the index laws. So I'm going to apply them all together. First, starting with the number. 5 cubed is 5 times 5 times 5. It's 125. I don't have any other term with 5, so I'm just going to put it as it is. And then you'll do a to the power of 6, b to the power of 3 over c to the power of 6. Now again, here it's the same concept like we did in the previous one. Division, change it to multiplication, use this as over 1. So times 1 over a to the power of 6, b to the power of negative 3, c to the power of 3. Now you can apply the laws of index. You'll get 125, a to the power of 6 divided by a to the power of 6, right? So 6 minus 6 is gonna be 0. And then do it for b as well. 3 minus 3, which is gonna be plus 3, right? And then c is in the bottom, which is in the denominator. So c will be 6. They are in multiplication with each other, so you add them. That is going to give you a final answer of 125 a to the power of 0, which can be replaced as 1. So I'm going to just leave that and then do the next one, which is b to the power of 6 over c raised to 9. That's it. That becomes the final answer for question B. Let's move on to a bit more complicated set of questions and see how we go. Now this question is asking you to simplify each of the following and express your answer in positive index form, which is what we have been doing, so it's nothing new. Just that you have to make sure at the end that all the index that you have, the exponents, they are all positive. So question A, to start with, this is already in its simplest form. You can choose to keep it as it is. So m cubed n squared p to the power -2, right? Now, this you can choose to put it in the denominator, make it positive exponent, or you can choose to bring down the exponent here and then simplify using loss. Both the methods are actually right, okay? Now, what I'm going to do is I'm going to bring this down to make it as a positive exponent. So that will make it mn squared p whole to the power of +3. Now that makes it m cubed n squared p to the power of -2 over, bring down the exponents for each and every variable. So m cubed, that will be m cubed, n squared raised to 3. That means power of power rule, 2 times 3 is 6, so n to the power of 6. Then p to the power of 3 is p to the power of 3. That's it. Now you can see all these have same basis up and down, right? Apply index law number 2. So because there is division in between, m is a common base, put it there. 3 minus 3, that will be here. And for n, it will be 2 minus 6. And for p, it will be -2 minus 3. Now you can actually choose to ignore this step completely, okay? And do it in your head and put the next step directly in the answer. I'm just doing it because each one understands the problem in, at a different pace. So that's why I'm doing it step by step. So m to the power of 3 minus 3 is 0, right? And this will be 2 minus 6. So 2 take away 6 is -4. And then p to the power of -2 take away 3 is -5. Again, the question says you've got to convert it into positive index form. M to the power of 0 is 1. Anything to the power of 0 is 1. So leave that, okay? We'll work on only this. Both have negative exponents, right? So that will be 1 over n to the power of +4, p to the power of +5. So you just have to move them to the denominator to make them positive. That's it. Now question B, again, first part, it's quite simple, and the denominator is quite simple. You have to work with the second part of the question. So let's simplify. You have x cubed y z to the power -2 times 2 as it is. Now bring down the exponent here, and then you will see that it is x to the power of 3 times 2 is 6. And then you'll see y to the power of -2 times 2 is -4. And then z to the power of 2 over x, y, z to the power of -1. Now what I will do is I will actually directly do them all together instead of doing them part by part. It's easy to do it together. So if I look at the numbers here, there's only 1, 2 here. That's going to remain at the start. Then x, y, and z are the only variables. So start with x. So x to the power of 3, put that 3 here. Multiplication with x to the power of 6. So that is plus 6. Because base is same, multiplication in between turns to addition for exponents. And then you have a divide and an x to the power of nothing. That means 1. So division becomes subtraction and put that 1. Okay. Again, I'll explain this once again. So x, I have an x cubed here, x to the power of 6 here, x to the power of 1 here. Now x cubed and x to the power of 6, there is multiplication in between. So I'm using plus between the exponents. And between this x to the power of 6 and x to the power of 1, I have a division in between. That changes to a subtraction. That's it. Now go to y. You can see here it is nothing, so 1, put the 1. And you have times y to the power of -4. That means it's plus minus 4. So plus minus is -4, okay? And then again you have take away because of the divide, and you have y to the power of 1, so put the 1 as it is. Now moving on to z, you can see it's a -2 here, put the -2. and then you can see times z to the power of 2. So times becomes plus 2. And then you can see denominator, division, that will be a minus. And then you have another minus 1. So division minus and this minus is going to change it to plus and then 1. Now let's simplify this. That's going to give you 2. X to the power of 3 plus 6 is 9. 9 minus 1 is 8. Okay. And then y will be 1 and minus 1 you can cancel. Negative 4. So that will be y to the power negative 4. Then same thing with z. It will be just 1 if you simplify that. Now again, it's not done yet. It has to be in positive index form. And you can see that the middle term, which is y to the power of negative 4, is in negative exponent. Move it down to make it positive. So 2, x to the power of 8, z to the power of 1 is z itself, over y to the power of positive 4. That's it. That's the answer for part B. Let's move on to part C. So here you can see that a squared b is already in its simplest form. Keep it as it is. And here you can see this also has a negative exponent. This also has a negative exponent, the denominator, right? I can choose to actually swap the positions of both to make them both positive at the same time. So what happens is I'm going to put this denominator on top as a to the power minus 2, b to the power minus 1 and raise it to positive exponent 2 over. I'll bring the numerator down and write it as ab to the power of negative 2 whole raised to positive 3. Okay. Once that is done, then you can apply as usual. Bring down the exponents for these two. So a squared b times 2 times negative 2 is going to be negative 4. And b to the power of minus 1 times 2 is going to be minus 2. Over. Bring down the 3 again. So a to the power of 3 and then b to the power of negative 2 times 3 is negative 6. Now apply index law for each variables separately. So we have variable a and then b. So let's start with a. You have a 2, so put the 2 here. You have a times in between and then a negative 4. So times is plus. Plus minus becomes minus. So put 4. And then divide becomes a minus. You have a 3, so put the 3. Then go for b. Here it is 1, so put the 1. You have times, which is plus, and then you have a minus. So plus minus becomes minus. Number is 2. Again, division is a minus, and then you have a minus 6. So minus 6. That means it becomes plus, right? That's it. Now you simplify. You get a to the power of 2 minus 4 is minus 2. Minus 2 minus 3 is minus 5. And then b to the power of 1 take away 2 is negative 1. Negative 1 plus 6 is 5. Again, change it to positive index form. So move this a to the power negative 5 down. So that will be b to the power of 5, which is already positive. Keep it as it is. Over a to the power of positive 5. That's it. That's the answer for question C. Now the next question is the last question, and that question is going to have variables in the exponents. Okay, it's pretty simple. It's very similar to how we did the previous, the number ones. It's gonna be the same, just that you will work with a little bit more algebra in this. So to begin with, we are going to work with same basis again here as well. So you can see here we have same base A, same base B, same base C. So base A, the numerator has got an exponent 2n minus 1. Now there is a division here, right? When you have division, you use negative. Now the thing that you have to be very careful here is when you have negative and you have a binomial, you got to use brackets no matter what. Okay, so that will be n minus 3 in brackets. Do the same thing with b. So b is the base, exponent is 3, division makes it minus, and this is a binomial, so put them in brackets. Okay, again c, the power of 1 minus n as it is. Division, make it negative. Binomial, put a bracket, 2 minus 2n. Now you gotta simplify. So when you simplify, first simplify the negative, take off the brackets, then it's easier, right? So 2n minus 1 as it is with no brackets. Negative times n will be negative n. And then negative times negative 3 is positive 3. Okay, and then next is b. 3 as it is. Negative times 2 is negative 2. Negative times negative n is positive n. Okay, and then for c, 1 minus n as it is. Negative times 2 is negative 2. Negative times negative 2n is positive 2n. Now you just have to combine the like terms. Okay, base is gonna be a. Combine the like terms. So when we combine the like terms, you can see that this term and this term, they are like. So 2n minus n is gonna give you n, right? And then minus 1 plus 3 is going to give you plus 2. That's it. We'll do the same thing for the next one, which is for b, and then we'll do for c as well. Okay. So when we are doing with b, we are going to see 3 minus 2 is 1, and then plus n as it is because there's no other like terms. Okay. For c, you can see you have 1 minus 2, that will be negative 1, and then you have minus n plus 2n. So minus n is basically minus 1n, right? Minus 1 plus 2 is plus 1n, which is just n. That's it. So this is the answer for this particular question. Hopefully, I think now you're a bit more confident on, applying these index laws, because learning these index laws is important, but at the same time, applying them in order to simplify the questions is even more important. So let me know in the comments if you have any questions, or if you have any particular question that you are kind of struggling with and not getting the answer, and I will help you out with that. All right. Thank you so much for watching.